In this video, we are going to apply transformations to square root functions. Before we begin with our example, let's recall that the base function for a square root function is f of x equals the square root of x. So to get the general form of the square root function, we're going to replace the x with bx minus h. In the base function, the x is being square rooted. So in our general form, we are going to square root the bx minus h. We then multiply by a and add v. So the general form of the square root function is f of x equals a square root of bx minus h plus v. So now let's look at the example. We would like to graph the function f of x equals the square root of x minus 6 plus 1. This function actually does not have the general form that is required to discuss the transformations. It is important to inspect what is happening inside the brackets, in this case inside the square root. It is not in the form b bracket x minus h. So what we need to do is factor out the 2 from the 2x minus 6. So we get f of x equals the square root of 2 x minus 3 plus 1. This function, written in this form, is the required form to discuss the transformations. So the transformations, the a value is 1 because there's not a number being multiplied outside the square root, so a equals 1. The b value is 2, which means there's a horizontal compression of 2. The h value is 3, which means there's a horizontal shift 3 units to the right, so there's a little typo there. And finally, the v value is 1, so there's a vertical shift 1 unit up. If you did not factor inside the square root, you still would have had the correct b value and the correct v value. However, you would have had an h value of 6. So your graph would have moved 6 spaces instead of only 3 to the right. So now we are ready to graph this function. So step 1 is to graph the base function. This is the square root function. So you have the key points 0, 0, 1, 1, 4, 2, and 9, 3. And then from here, we're ready for step 2, which is to apply the a and b values and draw the new function. So I have used Desmos to show what this graph would look like after the a and b values are applied. And I did this so you can clearly see where the points are instead of me estimating it by hand on the iPad. But I will talk about how we go from the key points on the red function, the base function, to this new function when we apply the a and b values. So again, a is 1, so there's no vertical stretch or compression or reflection in the x-axis. B is positive 2, which means there is a horizontal compression by a half, which means all of the x values are going to be divided by 2 or halved. And that means they're going to be half the distance away from the y-axis. So this first point, 0, 0, is on the y-axis, so it does not change because half of 0 is 0. This point here at 1, 1 has an x value of 1. It is 1 unit away from the y-axis. So now it's going to become half a unit away from the y-axis. And again, just be careful with our scale here because 2 boxes represents 1 unit. This next point, 4, 2, is 4 units away from the y-axis. So I'm going to half that, and now I'm 2 units away. So I'm right there at 2, 2. And then finally, this point, 9, 3 is 9 units away. So half of that is 4.5 units away. So it's going to be right here. So that's what you would do. You would graph those key points, and then you would graph your new function, which has the equation f of x equals the square root of 2x. and that is because we've not applied the shifts. In the third step, we are going to apply the h and v values. So h is 3 and v is 1, which means I'm moving 3 to the right and 1 up. So I'm going to take each point and move 1, 2, 3 units to the right and 1 unit up. So my graph now starts at 3, 1. So that point is now this point. And my graph at a half 1 moves 1, 2, 3 units to the right and 1 unit up. So at this point here, and then this point at 2, 2 moves 1, 2, 3 to the right and 1 unit up. So it's right here. And then finally, this point at 4.5, 3 moves 1, 2, 3 units to the right and 1 unit up. So we have those 4 points, and then you would just join those points together to get the required function. And then just make sure you label it. And then it's always good to check a point. So I've decided to check this point here. When x is 5, my y value is 3. So I'm going to substitute in 5 for x. And I'm just going to prove mathematically that I have 3. So I get the square root of 4 plus 1, which is 2 plus 1, which is 3. So I get an output of 3 when I put 5 into my function, which corresponds to the point 5, 3.